Hello scholars, this is part 1 of 2 of I Can't Even with the problems from solving exponential equations with logs homework. The first even problem is problem number 2. We are asked to solve for the variable using logarithms. Our first step is to isolate our exponential expression, which in this case is 7 to the y power and is already isolated. We can move on to step 2, which is to take the logarithm of both sides. We can identify the base of this expression, which is 7, the exponent, which is y, and the answer, which is 24. Rewritten in logarithmic form, it looks like log base 7 of 24 equals y. By utilizing the change base formula, we can enter log of 24 divided by log of 7 into our calculators and find that 1.6332 is our value for y. The next even problem is problem number 4. Our first step is to isolate our exponential expression, which in this case is 2 to the 3a power, and is already isolated. Using this expression, we can identify the base, which is 2, the exponent, which is 3a, and the answer, which is 142, and rewrite this in logarithmic form. Rewritten, this reads log base 2 of 142 equals 3a. Finally, we can use the change base formula to write this in a manner that we can put into our calculators. We can type in log of 142 divided by log of 2 to get us a value of 3a. This gives us 7.14975 equals 3a. Note that I kept 5 places beyond the decimal because I know that I'm going to need to round to the 4th decimal place. Finally, to isolate a, I needed to divide both sides by 3 to remove this coefficient here. This left me with my final answer of a equals 2.3833. Note that this is slightly off from my previous answer. I must have done some different rounding, maybe didn't keep my decimals the same way, but that's okay. Problem number 6 is the next even problem on this page. You can see that once again our exponential expression is already isolated. And we can immediately identify the base, which is 4, the exponent, which is 8n minus 2, and our answer, which is 84. Rewritten, this gives us log base 4 of 84 equals 8n minus 2. By rewriting using the change base formula, we get log of 84 divided by log of 4. And entering that in our calculator will give us 3.19616. We bring down the same expression as before, 8n minus 2. Now we can solve algebraically for n. Our first step is to add 2 to both sides, giving 5.19616 on the left and leaving 8n on the right. Finally, to isolate n once and for all, we must remove this coefficient of 8 by dividing by 8 on both sides. This gives us n equals 0.6495. The last problem on the first page of your homework is problem number 8. Our first step is to isolate our exponential expression, which in this case is 16 to the n power. You can see that in addition to that exponential expression, we have minus 6 on the left-hand side of our expression. We must remove this from this side by doing equal but opposite operations. This means adding 6 to both sides. We are left with 16 to the n power on the left and now have 51 on the right. Using this expression, we can now identify our base, exponent, and answer. Our base is here, our 16, our exponent is n, and our answer, a, is 51. Rewritten in logarithmic form, this reads log base 16 of 51 equals n. Finally, we utilize the change-based formula to calculate log of 51 divided by log of 16, giving us the value of 1.4181 for n.